Okay, question number 2 on problem homework number 7. The integral from -1 to 0 of -2 e to the x dx is, first, we're going to take apart the constant, just so you guys can see the problem a little easier. You don't have to do this, but when I'm first starting, I think it's nice to take it out. Now we know that this here is a straight identity. The integral of e to the x is e to the x. So we just write it. That becomes -2 e to the x. We do a bar, and we're at -1 to 0. And then we plug in -1 and 0. So when we take the integral of something, the integral from a to b of f of x dx is the integral f of b minus f of a, where f is the integral of f. Quick example, if f of x is x, capital F of x is x squared over 2. It's the integral. So we took the integral at this step, and now we plug in the 0 and then the -1. This is -2 times e plug in 0 minus e plug in -1. When I rewrite the problem, it's just -2 e to the 0. Anything to the 0 power is 1, and e to the -1 is minus 1 over e. You can rewrite that if you want with a common denominator. If I want to put an e down here, that's going to be -2 e over e minus 1 over e. I'm just rewriting it. So -2 e plus 2 over, oops, that should be an e. If I need to simplify it. I don't know what to include the answers. -2e plus 2 over e. Yeah. Okay. Now, if you guys have graphing calculators, if you guys want to spend some time working on the graphing calculator, since the AP exam now isn't, I don't think that calculators will help. Maybe some of the questions where they might have you to do calculations, but if you guys want to try this on your graphing calculator, you could do this. It's called, you hit the math button, and math 8 and 9. 8 is derivatives, and 9 is integrals. Let me see if I have a TI on here. If I hit math, if you look on the left-hand side, this kind of looks like your calculator. Math. See, it says n derive, or n function int, fn int. That's function integration. And we can actually do the same problem doing that. So if you, let me clear that up. If I hit math, then I'll go ahead and click 9. You can actually plug in your a and b value. My a, we said, was -1. -1. Darn it. I never used this before. Math 9. That's -1. On top, we plug in 0 of e to the x. E is here. Let's make sure for a second. Oops. Let's see. Come on. Second e to the x dx. 0.632. Let's see if that was my answer. Nope. Oh, I forgot the -2. Times that by -2. -1.64. So you can actually do this on your graphing calculator, and it should give you the same answer, negative 1.264. Now, if this was a regular AP exam, you would have to know how to do that on your TI-84 or whatever TI calculator you have. And that's one of the skills that we would have worked on. If you guys want, you guys can try that right now. Just take out your graphing calculator and work on these problems and plug in your definite integral. And you hit math 9. Let's go back to hit math. Hit math 9 because we want integration. And then you plug in the negative 1 and 0 and plug in the function. Okay. Any other questions on homework number 7? Is AB now calculator left? I think what happens is, even if you have a calculator, on the problems that don't need a calculator, it's not going to help. And on the questions that require a calculator, you have to know how to use it. I'll go back and read through the criteria of what they are going to have up on the test now, because things kept changing. So I'll go ahead and take a look at that. Also, you guys probably got an email from the College Board how they have live AP classes now. So if you guys watch those, sometimes I find them a little confusing though. We can go ahead and watch those. Those are free videos. Let me include the link right now, actually. Let me get that link. They actually have a website called apcoronavirusupdate.collegeboard.org. Let me pull up the link listed here. So if you look in the chat, I've included a link. And that's to all the AP videos that they've created. And then the second link here will be the YouTube channel where they have AP Calculus. Okay, there's 2 links there. One is for all the classes, and the second link is the playlist just for AB. Okay. All right. I let my friend buy my calculator. Oh, hey, that's great. I would just go get it. Like, go get it, throw it in a bag, and just leave the bag out for like a week. If not, you can just rub it down with rubbing alcohol. And rubbing alcohol shouldn't affect the circuits. Well, if you want to take out the battery first, then rub it down with rubbing alcohol. Like, don't flood it. Just get like a makeup Q-tip, makeup like a cotton swab, and just rub the whole thing down, or a tissue. If you want to mail it, the problem is mailing it is that it could get damaged. Maybe if you can have her parents drop it off or something, it's like do a drive-by, just throw it out the window. Any other questions on this homework? How'd you guys find the actual fundamental theorem of calculus problems? Like the first 5, 6, 7, 8, they're supposed to be pretty like ridiculously easy. Like this answer here, plug in, plug in, plug in. X squared plus 2x minus 4. That's it. This one is x cubed minus 4x squared plus 4. That's it. When we get into trouble is when we see problems like that. And the only difference is you plug in the value. We're going to plug in 2x squared plus 8, 2x plus 15. Okay? All right, we plug in, and you multiply by the derivative of what you plugged in, because that's chain rule. And that's just a 2. That's the only difference. On the problem on the right, same idea. It looks kind of funny with that exponent. Doesn't matter. It's 5, 2x to the 1/2 power multiplied by the derivative of 2x, which is 2.
That would depend which community college I go to.
Oops, sorry, I unmuted you guys. I should mute all of you. Do you guys have any questions? Nope. Do you guys have any questions when it comes to this? Thumbs up, thumbs down. Uh-oh. Allison, you have a question? Again, problem number 12 doesn't fit our fundamental theorem of calculus rule because we need a constant to be one of our endpoints, right, from A to B. So what we do is we cheat, we split it. So we use our rules from calculus, and integration can be separated into two separate problems. So we can come up with from x to some value c, so f of x, well, let's capital F. And then we're going to just copy it, negative, oops, t squared minus 2t plus 5 dt plus from c to x squared, where c is someplace between x and x squared. There's some constant. Then negative t squared minus 2t plus 5. And I think calculus is kind of cool because it teaches you to be a little flexible. If something doesn't look right, you adjust. You find a way to change it using our rules. Very algebra 2-esque. So, okay, this is the wrong order. So we say we can, this rule, if I go from A to B, f of x dx, this can be negative b to a. Just with a simple negative sign, you can flip your a and b value. So we're going to flip it with negative sign, negative integral from c to x of negative t squared minus 2t plus 5 dt plus integral of cx squared and negative t squared minus 2t plus 5. Okay. We did this problem on the left several times. If I take the derivative, plugs in. So we're left with negative of negative x squared minus 2x plus 5. Okay, I just plugged in the x, just plug in the x. Over here, I'm going to plug in not x, but x squared. So plus negative x squared minus 2x squared. Again, t's became x squared plus 5. That's a constant. And in this case, be careful because we have to do chain rule. And the derivative of x squared is 2x. Now you just got to simplify it. X squared, distributing the negative, plus 2x minus 5. Plus over here is, oh, sorry, not plus. Distributing the plus sign is negative x to the fourth minus 2x squared plus 5. And I'm going to multiply this by 2x. So multiply all that by 2x. So it's going to be a negative 2x to the fifth. 4 plus 1 is 5. Minus 4x cubed plus 10x. And then you might have some like terms here. So one question was, why do I have to flip it? We'll do that one first. The rule for fundamental theorem of calculus is when I'm taking the derivative of an integral of c to x of, let's do f of x, no, f of t dt. It has to be from a constant to a variable. That's what the rule is. So it only works when it's a constant to a variable, constant to a variable. And if you look back up here, when we look at all our examples, it was always from a constant to a variable, constant to variable, constant to variable, constant to variable. Okay? And the reason why is that's come up with a problem, some like lame problem. If I say d over dx integral from 3, make number 3, x of, let's call it t, dt. So that's actually do the problem. I'm sorry, maybe a little longer than you asked for. But if I take the integral of t, isn't that just t squared over 2? Plug in 3, plug in x. Okay. Then we plug in the x, so it'll be x squared over 2 plus 9 over 2. Because t squared, which is now 3, is 9. Cool with that? Now, if I take the derivative of this guy, hey, the derivative of this guy is bring down the exponent. 2x over 2, which is just x. We're back to our original problem, plus 0. So we don't have to write it. Now, if I have this in the wrong order, if I wrote d over dx of x to 3 instead, okay, only difference is I just flipped it. It's not going to be a simple plug-in. Now, looking here, if I gave you the variable on top and I just plug it in, that's the answer we get after we take the derivative, okay? But if I do the same thing here, remember, it's f of b minus f of a. So what happens here is we say, when we plug it in, let's copy this section here. It'll be d over dx of t squared over 2, plug in 3 and x. So it would be 3 squared over 2 minus x squared over 2. And we gain a negative sign. Hey, a negative sign. Now, if I take the derivative here of this problem, this is a constant, so it goes away. See you later. But we're left with a negative x, which is the same thing if I wrote instead d over dx. Sorry, if I wrote instead as this problem as a negative 3 to x t dt. That's your negative sign. So the rule says we want the variable always on top because we're just going to plug it in and get that positive version. If the variable was on bottom, you would always end up with a negative version. So how do we deal with this? We flip it initially, so we don't have to worry about the negative anymore. Okay, that's a good question. It's kind of cool. Like all these little nuances you work out, and as you do more problems, you figure out, oh, this is why this fits. This is why we do that. This is why we can't do something else. It's kind of discovering language. If you guys speak more than one language, you realize the more you use it, the more fluent you are, the more you're able to communicate with other people. And as you learn new words that you didn't know before, you're easily able to grasp it and then adapt it. Same thing with this math idea. So everything's all crooked. Whoops. The follow-up question was, do I have to write out a separate x to c and c to x squared? Yes, that is always the case. This is what the rule says. The rule doesn't say variable to variable. It never says variable to variable. If you're asking, can you just do it in your head? Yeah, you can do a lot of these steps in your head, but don't make dumb mistakes like forgetting to distribute the negative. But we write it out and we realize, hey, this guy gets a negative, not this guy, the front guy got the negative. So simple things. When it comes to doing fundamental theorem of calculus, it's actually very easy to apply. It's just getting your mind around it. And remembering that if it's not a nice clean x, you have to multiply by that chain rule. Let's do another problem when it comes to variable. Well, let's do this one. This one looks, number 14 looks terrible. Just looks terrible. It looks like, what in the world? I mean, number 15 looks a little fugly too. Sorry. Okay. Yeah, that's good. Okay. So the rule says this has to be a constant, which it isn't. So if it's not a constant, well, is there a way for me to make it a constant? And then actually, no. So instead, we're going to use our another rule in which allows me to split apart this integral. An idea of an integral, remember, is cumulative change. So if I go, let's give you a slight example. If I want to get from, let's say this is my paycheck from 1 o'clock to 5 o'clock, if I'm working from 1 to 5 of some type of wage based on time, couldn't I say this is the same thing as me making money from 1 o'clock to 3 o'clock? And then the same amount, then adding from 3 to 5 o'clock? Whatever I added, whatever I earn from 1 to 5 is the same. The paycheck would be the same as if I work from 1 to 3 o'clock, and then from 3 to 5 o'clock. It's the same idea. So what we're going to do is we're going to say, hey, we don't know what x is, but know what? I can guarantee you that there's some value c. C is between x and x squared, just some constant. So what we're going to do, we're going to break this up into two separate equations. The integral from x to c, stop, and then cosecant squared dt, plus the integral from that c value and finishing to x squared. I forgot the t. I'm sorry, with the t in the wrong place. Afterwards. Okay. So our rule always says constant to variable. This is constant. Wait, that's not a constant. So we're gonna flip it. And one of the cool rules about integrals is that you can flip it if you want to change the a and b value. So this is gonna be rewritten as a negative sign, integral from c to x, and nothing else changes. Okay. Now that we're in this nice way of saying constant to variable, we can just plug it in. We can just plug it in. So we're gonna end up with a negative cosecant squared x, done, plus negative cosecant squared x squared, and then you don't forget how to do chain rule. Okay. Okay, and then this one's plus cosecant squared x minus 2x cosecant squared x squared. So if we're looking at fundamental theorem of calculus, the whole point is that if I'm taking a derivative of the integral, they essentially should cancel each other out. And how does that work out? You just take the variable and you plug it in. If the variable, the derivative of that variable isn't 1, you have to show that the chain rule is applied. If I go ahead and take, what's the derivative of x? Isn't that just 1? Fine, you can write 1 here. Not going to change the problem. But if it's x squared, the derivative of x squared, that's going to be 2x.